Exercise number 5 says, as water drains out of a pool, the depth of the water decreases at a constant percent rate of 20% per hour. The depth of the water when the draining begins is 12 feet. So what I just did was I underlined and circled all of the important things. I'm going to make this into an equation. I have y equals our starting number, and then I have 1. This time we're going to use the minus symbol because we're decreasing. Percent, and then exponent is time. Off to the side, I would like you to write what equation you think we should use. So here I've got a y equals, and our starting is beginning 12, and then 1 minus. To write 20% as a decimal, it's 0.20. And it's draining each hour, and they want to know after 1 hour, so you can put a 1 there, or you can just leave that off. And then you get 9.6 feet. Now, using the same setup for part B, they say, what is the depth 12 hours later? Work on this on your paper, and then off to the side, write what you got for an answer. So when I write my equation, I have 1 minus 0.20. And this time, instead of a 1, I'm going to use a 12. And then I put that in my calculator, and I get 0.8. Now down here, we have our equation. It says dependent equals starting amount, parentheses, growth decay factor, independent variable. Well, that's just the math book way of saying y equals the start, 1 plus or minus the percent to the time. That's a formula you need to have memorized if we have a Regents exam. Okay, problem number 6. A population of fruit flies is growing at a constant, so growing means plus, constant rate of 6% per hour. Whenever I see that percent symbol, I know I need to convert it to a decimal. Okay, this grammar is a little weird. The population starts, I don't know why that's there, with 28 flies. So part A says find a formula that models the population, P, as a function of the number of time in hours, T. Off to the side, write down what formula you think you should use. So I'm going to start with y equals 28 is my starting, and it's growing, so 1 plus 0.06. You can use an X there. They want us to use P and T. Now, time is always in the X spot, so that means this P has to go over here. Population equals 28. Now, I can write 1 plus 0.06, or you can do this. 1.06 means the same exact thing. Now, part B says, what is the value of this, P of 24? Well, this was from a long time ago, chapter 4, I think. If you have a number in parentheses here, you're going to plug it into the X spot. So what this is saying, after 24 hours, how many fruit flies are there? It's kind of gross. So remember, we started with 28. 28 times 1.06. So in the T spot, I'm going to plug in a 24. And then when I put that in my calculator, I get about 113. So after one day, you would go from 28 flies to 113 flies. Gross. Now, exercise number 7, the actual equation got cut off. So it says if the savings in a bank account can be modeled by the function y equals 250, 1 point. Okay, so I just wrote an equation. Which of the following is true? So let's look at our initial amount. Come on. Our initial amount is right here, $250. So we can cross off this, 250, and we can cross this one off. So now it says, and the interest earned is you have an option of 45% or 4.5%. If we have a decimal, 0.045, and we want to turn that back into a percent, you take your decimal and move it the opposite way. So it's 4.5. So our answer is 3. All right, I'll see you back here for our last page.